Section 5.1 is on exponents. Our learning objectives are to evaluate exponential expressions, use the product rule for exponents, use the power rule for exponents, use the power rule for products and quotients, use the quotient rule for exponents, and define a number raised to the 0 power, and decide which rules to use to simplify an expression. I have listed here 8 rules for exponents. And in these rules, we're assuming that m and n, those exponents, are integers, and a and b, we call those the bases. Those are non-zero real numbers. I recommend that you write these down on note cards so that you can review them. So when you get to solving some of the problems later on in the section, that these will come naturally to you and you'll be able to apply the appropriate formula. Let's begin by evaluating each expression. For a, we have 3 to the 3rd power, and 3 to the 3rd power is the same thing as 3 times 3 times 3, and we know that that will equal 27. This is a good time to practice using that exponent button on your scientific calculator. That button will either look like a little caret symbol, or it will look like an X to the Y button, or it will look like a Y to the X button. That's your exponent button on your scientific calculator. Depending on which model you have, you want to use the calculator manual and learn how to use that exponent button. So the answer for part A is 27. 3 to the 3rd power is the same thing as 27. In example B, we have the quantity -7 to the 2nd power, so that is the same thing as -7 times -7, and that equals 49. Now, part C looks similar, but notice the negative is in front of the 6, not included in parentheses. So this is the same thing as -1 times 6 to the 2nd power. So we're going to write this as -1 times 6, which is the same thing as -1 times 36, or -36 is your answer. In example D, we have -4y squared when y is equal to -5. -4, I'm replacing the y with the -5. Notice that I'm putting that in parentheses. We want to make sure we square the entire y quantity. So this we can write as -4 times -5 to the 2nd power, which is -5 times -5. And that's going to be -4 times 25. And our final answer is -100. For these examples, we are using the product rule to simplify each expression. We want to write the results using exponents. Now the product rule can be modeled as b to the m power times b to the n power is equal to b to the m plus n power. In other words, when multiplying exponential expressions with the same base, add the exponents. Use this sum as the exponent of the common base. Let's look at example A. X to the 5th times x to the 3rd. Since the base here is x and the first exponent is 5, the second exponent is 3, we can use the product rule to simplify this as x to the 5 plus 3 power, and that's the same thing as x to the 8th power. If you want to think about it as writing x to the 5th is the same thing as x times x times x times x times x 5 times, and x to the 3rd is the same thing as x times x times x. And when you simplify that, you can see that there are 8 total x's. You're multiplying those together. So this is equal to x to the 8th power. Let's continue on with part B. Here we're multiplying the product 4z to the 3rd times 9z to the 5th. Now each one of these bases of z has a coefficient, so we can write this as 4z to the 3rd times 9z to the 5th, and we multiply the coefficients together, 4 times 9, and then we're multiplying z to the 3rd times z to the 5th. When we simplify the next step, we know 4 times 9 is 36, and z to the third times z to the fifth, we add those exponents together. So when we simplify our answer, we're going to get 36z to the 8th power, and that is our answer. Let's continue with C. Here we have the quantity negative 3x to the third y squared times the quantity negative 5x to the fourth y to the sixth. Here we're multiplying. We can multiply the coefficients together, negative 3 times negative 5, and the common bases, x to the third times x to the fourth, and the common basis for y, y to the second times y to the sixth. We can combine these coefficients, multiply the coefficients to get a positive 15. You add the exponents, x to the third and x to the fourth, that's x to the 3 plus 4. You add those exponents together. And for the y's, y to the second times y to the 6 is y to the 2 plus 6 power. And then we simplify those exponents and write it as 15 x to the 7th times y to the 8th. In example D, we're multiplying three quantities. The quantity 9ab squared c to the fourth times the quantity negative 11a cubed b times the quantity negative 2b squared c to the fifth. We begin by multiplying the coefficients. So that's going to be 9 times negative 11 times negative 2. And then we're going to multiply the a terms together, a times a to the third times, and then the b's, b to the second times b to the second, and then the c's. So we have c to the fourth times c to the fifth. So using the product rule for exponents, we are going to begin by multiplying those coefficients together. And that's going to be 9 times negative 11 times negative 2, which equals 198. And then we are multiplying the a variables. This is the same thing, a by itself is the same thing as a to the first times a to the third. We add those exponents together, so it's going to be a to the 1 plus 3 power. And then the base b is going to be adding those exponents together, b squared times b, which is b to the first, times another b squared. So that's b to the 2 plus 1 plus 2 exponent. And then the base c, c to the fourth times c to the fifth, we add the 4 and 5 exponent together. Now we can simplify this answer as 198, a to the fourth power times b to the fifth power times c to the ninth power. So that is the simplified form of our original problem. For these examples, we want to use the power rules to simplify each expression. Let's review the power rules. The power rule, also called powers to powers. For example, we have the quantity b to the m power, that entire quantity raised to the nth power. That's the same thing as b to the m times n power. When an exponential expression is raised to a power, multiply the exponents. Place the product of the exponents on the base and remove the parentheses. Now we're also going to be including the product of powers rule, where you have the quantity ab to the nth power is equal to a to the nth times b to the nth. When a product is raised to a power, raise each factor to the power. So let's use these rules to simplify each of those expressions, beginning with a, x to the seventh to the third power. So using the power rule, or power to a power, we're going to take the base x to the seventh power times that third power. So you multiply the exponents. When you do that, your final answer is x to the 21st power. So if we want to go back and determine if this answer is reasonable, another way to write x to the 7th to the third power is the same thing as x to the 7th times x to the 7th times x to the 7th, x to the 7th to the third power. And then using the previous rule, the product rule, you add those exponents together, x to the 7 plus 7 plus 7, which is the same thing as x to the 21st power. So now that we know the power rule, we can simply multiply those exponents together. So our simplified answer is x to the 21st power. Let's continue with example B. We have the quantity y to the third raised to the 11th power. Using the power rule, or power to a power, we're going to multiply the exponent 3 times the exponent 11 to get our final answer of y to the 33rd power. For example C, we have the entire quantity xy all raised to the 5th power. In that case, we're using the products to powers. We have the quantity ab to the nth power is equal to the a to the n times b to the n. When a product is raised to a power, raise each factor to that power. So we can write this as x to the 5th times y to the 5th. And there's nothing else to simplify. The bases are different, so we don't want to combine those at all. And our final answer is x to the 5th times y to the 5th. Now let's continue with D. We're combining both of these rules to simplify this expression. We see this 3 on the outside here. We want to share that with all of the factors. So we're going to have this as 5 to the 3rd power times x to the 3rd power times y to the 2nd to the 3rd power times that final factor z to the 3rd power. And then we're going to apply those product rules. So 5 to the 3rd is the same thing as 125. X to the 3rd, using that power to a power, the power rule, we're going to multiply the exponent 3 with that outer exponent of 3. And then the same thing with the y's, y to the 2nd power to the 3rd power. We're going to multiply the 2 and 3 together, and then the z to the 3rd. You could also consider that as a z to the 1st times the 3rd power. And then when we simplify this, we're going to multiply those exponents together to get 125x to the 9th power, y to the 6th power, and z to the 3rd power as our final simplified answer. We're going to continue to use the power rule for products in example A, and then we'll use the power rule for quotients for the rest of the examples. In part A, we want to take this exponent 2 and make sure we raise each factor in the parentheses, raise that to the 2nd power. So we begin with the -7 quantity raised to the 2nd power, the a to the 3rd power raised to the 2nd power, and the b to the 3rd power raised to the 2nd power. Then we can simplify this. And -7 to the 2nd power is 49. A to the 3rd to the 2nd power, we're using that power to a power rule where you multiply the exponents. And then the same thing with b to the 3rd to the 2nd, you're going to multiply those exponents together. And then we can simplify this as 49, a to the 6th power and b to the 6th power as our final answer. Now in the next set of examples here, notice you have quotients. So we're using the quotient to powers rule, where you have the quantity a divided by b all raised to the nth power. You want that power n raised to the numerator and the denominator to equal a to the n in the numerator divided by b to the n in the denominator. When a quotient is raised to a power, raise the numerator to that power and divide the denominator to that power. Divide by the denominator to that power. So when we do this, we want that exponent 7 to be given to both factors in the numerator. We can write it as ab to the 7th power in the numerator and c to the 7th power in the denominator. But we want to go a step further. This 7, we want to distribute or make sure each factor in the numerator is raised to that 7th power. So we can write this as a to the 7th, b to the 7th in the numerator divided by c to the 7th, and that is our final answer. Let's continue with example C, where we have the quotient, and we also have a product in the numerator. So we can write this as -3xy, the whole numerator to the 4th power, and the whole denominator, z to the 3rd to the 4th power. And when we simplify the numerator, we're going to raise each of those variables to the 4th power. So we're going to write this as -3 to the 4th power, x to the 4th power, and y to the 4th power. And in the denominator, notice we have z to the 3rd to the 4th power. Using the power rule, we're going to multiply those exponents together. So let's simplify this. as negative 3 to the fourth power is a positive 81, x to the fourth, y to the fourth in the numerator, and in the denominator we multiply the 3 and 4 together to get z to the 12th. And that is our final simplified answer. Let's continue with example D. We have this power 2. We want to raise the numerator to the second power and the denominator to the second power. So we have 3x squared y to the fourth, that entire quantity raised to the second power in the numerator, and negative 2z to the third, that entire quantity raised to the second power in the denominator. So we want to raise each factor in the numerator to the second power. So that's going to be 3 to the second power, x to the second power, y to the fourth to the second power, and then in the denominator, negative 2 to the second power, and z to the third to the second power. Let's simplify this. We know 3 squared is 9. X squared to the second power, when you have a power raised to a power, you're going to multiply those exponents together to get x to the fourth. Y to the fourth to the second power, we multiply 4 and 2 together to get 8 in the numerator. And the denominator, negative 2 to the second power, that quantity negative 2 raised to the second power is 4, and z to the third to the second power. When you have a power to a power, you multiply those exponents together. So our final simplified answer is 9x to the fourth, y to the eighth in the numerator, divided by the quantity 4z to the sixth in the denominator. In these examples, we will be using the quotient rule to simplify each expression. Now, the quotient rule is where you have a quantity b, base b to the m powered, all divided by base b to the nth power. When you're using the quotient rule and you're dividing, the bases are the same, you're going to subtract those exponents. So that will equal b to the m minus n power. When dividing exponential expressions with the same non-zero base, subtract the exponent in the denominator from the exponent in the numerator. Use this difference as the exponent of the common base. So let's begin with example A. X to the fifth divided by x to the second power. We're using the quotient rule here. Since the bases are the same, we can simplify this by subtracting the exponent. So it's x to the 5 minus 2 power, which simplifies the x to the third power. In example B, we have the quantity negative 6 to the 11th power divided by negative 6 to the 9th power. Notice that the negative 6 base is the same for the numerator and the denominator. So we can write this as the same base, negative 6 raised to the power of 11 minus 9. And then when we simplify this, we have negative 6, 11 minus 9 is the second power, and we know negative 6 to the second power is 36. So our final simplified answer is 36. In example C, we're going to use the quotient rule for the base x and the quotient rule for the base y. So we have, notice the x to the 12th in the numerator and the x to the 8th in the denominator. So we can write this as x to the 12 minus 8, and the y to the 5th divided by y to the 4th, it's y to the 5 minus 4. And then we can simplify this. X to the 12 minus 8 is x to the 4th power, and y to the 5 minus 4 is y to the 1st power. It's not necessary to write that one exponent, so we can write our final answer as x to the 4th y. Okay, let's continue to simplify example D. Notice the coefficients 8 in the numerator and 18 in the denominator, so we are going to write that as 8 divided by 18, which we'll be able to simplify that. Let's look at the common bases of a. We have a to the third in the numerator and a by itself in the denominator, so that's the same thing as a to the first power in the denominator. So with the quotient rule, we're going to subtract those exponents. So a to the 3 exponent from the numerator and an a to the first, so it's 3 minus 1. And then looking at the b base, b to the 8th in the numerator, b to the 5th in the denominator, so it's b to the 8 minus 5. Quotient rule, we're going to subtract those exponents. And then finally, the c to the third in the numerator and c to the second in the denominator, we are going to write this as c, that common base c, raised to the 3 minus 2 exponent. Now we can simplify. When simplifying 8 over 18, notice that those are both even numbers, so you can simplify this by dividing both the numerator and the denominator by 2, and that fraction simplifies to 4 over 9. And the a is to the 3 minus 1 power is the same thing as a to the second power, and then b to the third power, because 8 minus 5 is 3, and then c to the first power, 3 minus 2 is 1. So our final answer, you can write it as 4/9 a to the second b to the third times c, or you can write it as 4a squared b to the third c, all divided by 9. For these examples, we want to simplify each expression. Now notice that each exponent that you see is a 0. We're going to use the zero exponent rule to simplify, which states that if b is any real number other than 0, then that base b raised to the 0 power will always equal 1. So let's simplify the first example, 8 to the 0 power. That is the same thing as 1. And then that's our final answer. That's as simple as that. 8 to the 0 is 1. And then if we're looking at example F, 3/7 to the 0 power, we can think of that as using the quotient rule, 3 to the 0 over 7 to the 0, which is 3 to the 0 in the numerator is 1, and 7 to the 0 in the denominator is 1. So the final answer here is 1. All right, let's continue with example G, where we have 5x squared y all raised to the 0 power. You want to make sure that 0 power is raised to each term, each factor. X, so we have 5 to the 0, x squared to the 0, and y to the 0 power. And when we simplify that, 5 to the 0 power is 1. X to the second to the 0 power is x to the 0 power. And y to the 0 power. Now y to the 0 power and x to the 0 power are both 1. So it's going to be 1 times 1 times 1, where our final answer is 1. And then finally, our last example here, we have x to the 0 plus 9 to the 0. Well, since x to the 0 is the base x to the 0 power, that's going to equal 1. And 9 to the 0 power is also equal to 1. Then our final answer is 1 plus 1, which is equal to 2. In these examples, we consider this mixed practice. We decide which rules to use and simplify each expression. So in example A, I see the entire quantity of 8a to the third, b to the second, c to the 0, all raised to the second power. So we want to make sure that that power of 2 gets used for each of those factors. So we're going to write this as 8 to the second power times a to the third to the second power times b to the second power times c to the 0 to the second power. Now we're going to simplify each one of these factors. 8 to the second power is 64, and a to the third to the second power, since it's a power to a power, we multiply a to the 3 times 2, and then b to the second power is b to the 2 times 2, and then c to the 0 to the 2 power is 0 times 2. So let's simplify this as 64 a to the 6th power times b to the 4th power times c to the 0. But we know that c to the 0 power is equal to 1. So we can write this as 64 a to the 6th b to the 4th times 1. Or our final answer is 64 a to the 6th times b to the 4th. All right, let's continue on with example B. We have that exponent of 3 here. We want to raise that to the entire numerator and the entire denominator. So we're going to write this as negative 3x squared y to the 5th, that quantity in the numerator to the 3rd power, and 2xz squared to the 3rd power. We want to share that power with each term in the numerator and in the denominator. So that's going to be a negative 3 to the 3rd in the numerator, x squared to the 3rd in the numerator, and y to the 5th to the 3rd in the numerator. And then in the denominator, we're going to have 2 to the 3rd, x to the 3rd, and z squared to the 3rd power. We can continue simplifying this. We know negative 3 to the third power is negative 27. By using the product rule, or power to a power, x squared to the third, we multiply those together. So it's 2 times 3 is 6. And in the numerator, y to the fifth to the third power, it's y to the 5 times 3 power, y to the 15th power in the numerator. In the denominator, 2 to the third is 8, x to the third, z to the second to the third power is where we multiply 2 times 3, z to the sixth power. Now we're not quite finished simplifying here because notice we have x's in the numerator and the denominator. We want to continue to simplify this. So this negative 27 over 8, there's no common factor, so we can't simplify that, but we can simplify the x terms. We have x to the sixth divided by x to the third, and when you use the quotient rule, you're subtracting the exponents, so it's going to be 6 minus 3 as the exponent. And the y to the 15th, there's no other y, so we're going to leave that y to the 15th and z to the sixth in the denominator. Let's simplify this. As one fraction, we can keep that negative 27 in the numerator. X to the 6 minus 3 is x to the third in the denominator, y to the 15th in the numerator, and then 8 and z to the sixth in the denominator. So that's our final simplified answer. Let's continue with example C. We have this entire quantity times this entire quantity. We're going to use the product rule. So let's multiply the exponents, the a's, the b's, and the c's. So when we multiply the coefficients, negative 4 times negative 6, and then it's going to be a to the second times a to the third, b to the second is by itself, and c to the third times c to the fifth. We're going to use the product rule. We're going to multiply negative 4 and negative 6 together to get a positive 24. Then we're going to add those exponents. When you are multiplying and the bases are the same, you're going to add those exponents together. So it's a to the 2 plus 3, b to the second, and c to the 3 plus 7. And then let's simplify it. We get 24, a to the fifth, b to the second, and c to the 10th as our final answer for example C. Okay, for example D, we have the quantity 12ab to the fourth divided by the quantity 6a squared b squared, all of that to the second power. So let's begin with multiplying the whole, or making sure that whole numerator is raised to the fourth power. So that's going to be 12 to the fourth power, a to the fourth power, and b to the fourth power in the numerator. And in the denominator, we're going to raise each of those factors to the second power. So it's going to be 6 to the second power, a squared to the second power, and b squared to the second power. Let's simplify this. So in the numerator, 12 to the fourth is 20,736, a to the fourth, b to the fourth in the numerator, and then in the denominator, 6 squared is 36, a squared to the second power is a to the fourth power, b squared to the second power is also b to the fourth power. Now we can simplify using the quotient rule. We have 20,736 divided by 36. That does simplify to 576. And then notice we have an a to the fourth divided by a to the fourth. So we can use the quotient rule, a to the 4 minus 4. And the same thing with the b's. A b in the numerator, b in the denominator, you subtract those exponents. And then we can simplify this as 576a to the 0 power, b to the 0 power, and we know that both a to the 0 and b to the 0 are equal to 1. So this is the same thing as 576 times 1 times 1, with our final simplified answer as 576.